G'day guys, it's Dan back with another video for you today. This video here is just a follow-up video for a older observation of the Bathurst Lighthouse observation that I've previously done. So enjoy. The natural physics of a body of water at rest will always find its own level. That's flat at the top and conformed to any shape of the object that it's in. For my location today, I was 2.16 feet above sea level and I was 14.35 miles away. Now the hidden target distance should be 105 feet below the distance of the horizon. Now the Bathurst Lighthouse from sea level to the top is 108 feet. And I think anyone can agree that we shouldn't see more than 3 feet of the Bathurst Lighthouse. Now, just to make it clear, what you're seeing here is not a mirage. Now, as you can see here, I mean, it's not the clearest shot. This was taken probably at about 10 AM in the morning, and it was starting to get pretty hot. But it's clear the Bathurst Lighthouse is right there. I'm 14.35 miles away and my tripod is 2.16 feet from sea level. This disproves the curvature model right there. It's plain and simple, guys. There is no curvature to be seen here, okay? The Earth is not a planet. It's not spinning on its axis. We're stationary. We've got to start to use our senses again and understand what we can deduce from nature. Okay, so as you can see, the Bathurst Lighthouse, it's on the curvature model. It's supposed to be 105 feet below the curvature of the Earth right now, but there it is in all its entirety. So what I want to do right now is just get a screenshot of the first time I've photographed the Bathurst Lighthouse. If you're not familiar with that, just go through some of my other videos and you'll see the Bathurst Lighthouse one. This one's from 12.3, I think, miles away, so it's two and a bit miles closer to this observation. And I was at, I think, 10 feet high as well, and this one's at 2.16 feet. So as you can see, not much difference. I just wanted to show you that to get a bit of understanding of the different locations and how you can still see the entire Bathurst Lighthouse. Now, speaking of that first location, I actually decided to make a quick trip to that location straight after I'd finished filming from the South Coogee observation that you had just seen. Now, this was at 12.43 miles and it was still at an observer height of 2.16 feet. Last time I filmed here, I was at 10 feet elevation from the same location. Now, what we're going to do is just take a screenshot and just overlay it from what we're seeing now. Now, as you can see, this is going through a lot more denser atmosphere. It's a lot later in the day, and it's a lot more compressed. Same location, one's at 2.16 feet, and one is at 10 feet. Now, I don't know about you, but even though it's compressed and the picture's a little bit fuzzy, it matches up perfectly. And there is not much difference in the height of observation. So what I wanted to quickly show you guys is something interesting that's caught my attention from both of these observations today. What we're having a look at here is from the second location. Now, it's quite interesting that the Wajimup Lighthouse is not compressed, but from the first location, when we were at 14.35 miles away, this is the shot that I captured of the Wajimup Lighthouse. Now, as you can see, the compression is just huge in the just above the surface of the ocean. So yeah, I just wanted to show you that, guys. That's at probably a distance of, I'm not sure, I think it was about 7 to 10 miles away, probably at about maybe 45 minutes difference in time. So what I want to do now is just compare 3 different locations in which there was observations taken of the Bathurst Lighthouse. 2 of which, location A and C, were mine, which you have just seen, and location B was where Woolfie6020 taken the footage of his Bathurst Lighthouse, of which he claimed he could see the curvature of the Earth, and was even telling onlookers that that's what he was seeing. Now, as you can see, location A, B and C all up against each other, and Woolfie's was the only one that apparently there was curvature. And what I have done here, I've just put my location A on the same day as location C, and again, there is absolutely no curvature to be seen. You can see the entire Bathurst Lighthouse. This was another shot that I had taken at location A. This was on a completely different day, and as you can see, what I had captured was almost the same as Woolfie's. Now, this is obviously just standard refraction. This is the horizon merging with the sky, and there is so many different conditions as to what has happened and what's basically caused this. But yet again, Woolfie claims curvature while staying ignorant to all of these atmospheric conditions. Now, I'm just going to leave you guys here with a short clip from Flat Earth Perth. He does an amazing job at explaining how we basically perceive the horizon from the ocean and the sky meeting together over large bodies of water. And he goes through all of the atmospheric conditions and much more.
So for the Globers who ask why you can't see forever out into the ocean, here is your answer. You can't see past the mirror zone. You guys have mistaken the wall of water to be the horizon line. Now, guys like Ranty, Wide Awake, myself, and every other flat earther out there who films over water knows that conditions change every day. And where the horizon line sits also changes every day. So how can the horizon line change every day? That makes no sense until you realise that this line is simply the start of the mirror zone. Let's now look at an example of this. If we place a white rectangle over the mirror section, you see how the channel marker should appear. If we take the white rectangle away, we see the reflection of the channel marker again. Okay, but how does this cause the bottom of islands to be obstructed? Have a look at the channel marker on the right there. It's not actually that high, is it? The bottom part of it is a reflection. So that reflection caused by the mirroring would cause any objects in this zone to not be seen. All you would see is the mirror surface and any reflections. But what if the channel marker was sitting on a little island? The mirror zone prevents us from seeing the island. Again, all we would see is the mirror and any reflections. And if that mirroring disappeared, the island would come back into view.